So, okay, everybody, I'm recording this so that you know how to switch workspace, even though that is in the video. Okay, so to get organized so that you can always find your files, find your classes, your programs, let's create a folder. I'm just going to create it on my desktop. Okay, good, you opened it. So on your desktop, just click new folder, right? Okay, I'm going to call it COSC 1436 003. So now we have a new folder, right? Okay, good. Now you go back to your Eclipse and go to File and go down to Switch Workspace. Workspace is simply the default folder where you create your projects. Okay, so switch and click Others. And this is where you find it. So let's go to Browse. This is the workspace, right? Okay, so browse and find your folder. Remember, mine is on my desktop, COSC 1436. This folder. So I will use that folder. Okay, click on it and then select that folder. Okay, so now when you create your projects, it will be in this workspace. That means all your programs will go into that folder. Okay, so you have it will restart because you are changing the workspace. If you look at recent workspace, I have, this is where my recent workspace is, but now I have changed it, I have to relaunch it. So Eclipse will restart. Oh. Okay, so because I changed the workspace, it's a brand new place, so it gives me this welcome page. I'm going to close it, right? And you see, because it's a new workspace, my original files are all gone. This is because it's a new folder. So let's create a new project. And you do remember, if you do not see this, you do remember that you go to Window. If you don't have the Package Explorer, go to Window and Show View and go to Project Package Explorer. Okay. And you have this window. Okay, now let's create a project. We can just do this, or you can go to File, either way, right? I'm going to stop recording right now because we have done that already. So after the class name, you must have the beginning curly brace and the ending curly brace, because that is the beginning and ending of the class, of this class. And remember, every statement, every method must be within the class body. Okay, you cannot write something here. You cannot do that. So everything must be within this class body. Okay, so within the class, you will always have a method. And also, usually when you press Enter, it automatically indent. Indent means the tab key, right? There is a tab. If it doesn't indent, you need to press the tab key to indent it. Why? Because this is a level within the class level. This is not the same as the class. This is the method. So it is within the class. We tab it, indent it to express the level, the organization. Okay, so let's type public static void. You need to remember these. Okay, main. And remember, every method, every class must, not every class, every program must have a class. At least one of the class must have the main method, okay? So, because this is where the operating system starts it. So string, square brackets. Okay, so after the class, after the method header, you always also have the beginning and closing curly braces because that is the method body, right? Press enter and notice that automatically it's indented. And once again, if it's not, you must do that, okay? Tap in. So that you, right now you can see you have 3 levels. One is the class, one is the method, and then the statements. So this is clearly organized. And when you read this code, it's easy to understand. Let's type the statement. System.out.println, right? So that is a must. You must, these are written by the Java programmers, Java developers. So you are using their code, really. Okay, and now you're using their code to write your own code. So after this print line, you must have the parenthesis, and within the parenthesis, whatever you want to display, whatever you want to display must be within the quotation marks. So, okay. And if you want to do that, you know, whatever you want to display, whatever you place into the quotation marks, it will display. Okay. So go to the end. Remember, this is a statement. You will always have to have the semicolon to end it. If you don't, you will see there is a compiling error. And notice that red X. If you point to it, it tells you what error it is. So you will correct that error on your own. Okay, so let's put the semicolon there. And now we have finished this program. And we run it. And usually you format it well. So I like to format it so that it looks good. Okay, so now you delete those extra white space. And this is your program. And run. And this is what you displayed, right? You're displaying something there. Okay, any questions, everybody? So one of you asked, can we edit the font size? Yes, I don't remember exactly where, but let's go to, I think, Windows, Editor, Appearance. No, Editor. Okay, I'm going, let me not record this part, it takes time, right? So to change the font of the program, a quick way, a shortcut way you mentioned is to Control plus, no, is it Control plus? Oh, here. Control plus or Control minus to decrease the font. So that's one way, okay? That's good. Another way is to go to Windows, Window, and go to Preferences. And okay, they're all here. You can type colors and font, or you can go to General and Appearance. Okay, oops. Appearance, and go to Colors and Font. So either you type the text key term here, or you can just click General Appearance, it's here. Colors and Fonts, and then go to Java, and you can do your thing. So click Java Editor Text Font, and click Edit. And you can change the font here. Okay, I'm going to change it to 14. And there is a place where you can change the color, not color, the background. I forgot where that is, but yeah, somewhere, you know, you can always explore this and find how to change the background color. I changed it, but now I forgot where. Okay, so that's how you change the color, the size of the font, and you can change color too and apply.
Dr.
Yes,
Z, I have
yes.
a question.
Mhm.
I have a Mac and I don't see that on mine. I see perspective, but I do not see preferences.
Not perspective, preference.
Yes, I don't see preference.
Yeah, on your Mac, you don't have preference.
No, I don't see it. You said
Window
look
and
under
no
under
preference.
window, right? Yeah, no
Yeah.
preference.
Okay, I will look at it afterwards.
Okay.
Okay, good. So that's how you change that, everybody. Okay, so now we will talk about this. If you have questions, just let me know. Okay, white valid identifiers. And that means you cannot have a space in it. You cannot start with a digit. You cannot use special symbols. You can only use underscore and letters and digits, but you cannot start with a digit. Okay, those are the rules. White space. Spaces, blank lines, and tabs are called white space. White space is used to separate words and symbols in the program to make it formatted, to make it easy to understand. It's ignored. So if you look at this program, okay, this is white space right here, right? Here. This part, before system, this is white space. And that is ignored. And this is white space, okay, here, right? So white space is ignored. And if you do this, you have this white space. So these are ignored by the compiler. But you always want to use it to organize your code. And so this white space, this is necessary because it makes it leveled and organized. And this white space is necessary. Let me ask you, is this white space, everybody?
No.
No, that's good. It's not, because it's part of the text you want to display. So it's not white space there, okay? This is the text you want to display, this part, okay? So that's white space. Any questions? If you look at this, this is a terrible program because it's not formatted. Does it run? Definitely. Remember, the compiler ignores white space. So even if you don't have the correct white space, it will run. But it's terrible for humans to read, right? So this is not a well-formatted program. The compiler will give you a pass. It will say, okay, you're okay. As a human reader, I would say definitely terrible. So you don't want to do this. And look at this versus this. You want to make it formatted, okay? Terrible formatting. And so program development, you have experienced this just now. So what do? You start the program. In our case, it's the editor. In our case, it's the Eclipse. And then you write your program, you edit, right? And then you save. Automatically, it's saved. And then the program will compile. The compiler will compile. If you have errors, it will go back. So you have to change it, modify it, correct it. And if everything is good, when we say everything is good, everybody, what does that mean? What does everything is good mean? What did I mean?
Means that everything is good, and you can run the program.
Yes, so everything, no errors. No, what kind of errors? What kind of errors are we talking about?
Syntax?
Syntax, very good. Syntax errors, yes. Okay, syntax errors. Your compiler can only catch syntax errors, okay? So if there are syntax errors, it will not compile. Once it's clean, it will compile and it will execute. Why? Where is that line? There should be a line here. I don't know where it is. Okay, there is a line. So once it's compiled, it will go to execute the program and evaluate the results. If there are errors here, you go back to re-edit your program. So that's the process. It's a circular process. Okay, just like when we write this, if there are errors, it doesn't compile, we go back. And if what we displayed is not what we meant, we go back and recode. So this is once again a circular process. Okay. Any questions? Okay. Language levels. There are 4 language levels: programming, machine language. Machine language is zeros and ones. We call that binary. Bi, as you know, means 2, right? Binary, that means it has only 2 digits, 0 and 1. Okay, so that is machine language. Assembly language is a little bit above machine language, but it's very native to the machine still. It uses mnemonics. That means little terms to represent the binary digits. Okay, high-level language, which is what we are using. Java, that's high-level language. C++, Python, they are all high-level language. And then 4th generation language means the 4th generation language is the language that using block, that uses pictures, blocks. You can drag a block and then it becomes a program. You combine the blocks, okay? So each type of CPU has its own specific machine language. So if you are using an Apple, the Apple CPU speaks a language, a little bit different syntax, and Intel's chip or Microsoft PC, the PC speaks another language. So that means the hardware is different. Therefore, the zeros and ones, the arrangement, the meanings of those zeros and ones are different. So in on one computer CPU, this means something. This means 1, maybe. Okay, on another computer, this means 1. So that's why we say each type of CPU has its own specific machine language. Okay, the other levels were created to make it easier for a human being to read and write programs. So the lowest level is machine language, and that's this. The highest level is high-level language application. Actually, that is the programs written with language, with high-level language, and in between. So you have low, which is machine language, application here, which is written with high-level language, and in between you have many layers, and those levels were created to make it easier for human beings to read and write programs. Okay, so this level will interpret this, and this will interpret this, and this will interpret this. So it interprets each level until the machine can understand it. Any questions? Okay, so and this is a high-level language here, okay, A plus B right here, and this is assembly language. You see, it's not completely ones and zeros, but it's difficult to understand. You have to learn it, right? And this is the machine language, zeros and ones. So This is interpreted to in assembly language and then to this, right? Okay. That is that. So at the machine level, your computer can only understand ones and zeros. Any questions? Each type of CPU executes only a particular machine language, and we talked about that. Apple computers' machine language is different from PC's machine language, okay? Because the hardware is built differently, the chip is built differently, the circuits, the little copper tracing, they are different. So the interpretation is different, okay? A program must be translated into machine language before it can be executed. Why? Because we write a program using high-level language, and machine language is composed of what?
Ones and zeros.
It's zeros and ones, right? So your high-level language like this has to be interpreted into, has to be translated into zeros and ones like this. Okay, so and a compiler is a which translates source code into a specific target language. So remember, each CPU is different. Each CPU, central processing unit, has a different language, machine language. So a compiler is a tool. A compiler is a program. It's a tool. It translates the source code, which is this, right, into a specific target language. Often the target language is the machine language for a particular CPU type, but Java is different. That's why we say a target language. We didn't say directly machine language because it's different. All other languages directly translates your program into the CPU language, but in Java, it's different. So let's see how different it is. A program is written in an editor, like Eclipse, we did that, compiled into an executable code, and then executed. So edit program, translate program into executable code, and then execute, right? This is the basic programming steps. So 3 steps. You write the program, you compile it, and then the compiled machine language will run. So when you compile, it translates it into machine language already, and then you run it. That is the basic programming steps. So I'm just, again, expanding a compiler so that you understand it. I will let you read. Okay, so a compiler has 2 functions. It checks grammatical errors, syntax errors. If it's cleanly done, it's correctly done, it translates it into into machine language so that it can execute. Those are the 2 functions. Checks syntax errors, translated into machine language. That's what a compiler does. But Java is different, everybody. I will let you read this. Okay, so you remember for other languages, for other programming languages, the process is you write the program and the compiler checks syntax. If everything is correct, it will translate it into machine language, right? And then that machine language will be executed. So that's it. Write, compile, and execute. In Java, though, it's different. So the Java compiler translates Java source code not directly into machine language, but into a special representation called bytecode. Okay, so that's the keyword, bytecode. And Java bytecode is not the machine language. That's the difference, right? It's not a machine language for any traditional. It's a specific language that is handled by Java virtual machine. This is a virtual machine. It's not real. So what is a virtual machine? It's a program, right? So this is in the Java system. That's why when you do this, you see you have this JRE right there. That includes everything, right? So you must have that. So the bytecode is handled by the Java virtual machine, which is a program which translates the bytecode. Remember, this bytecode is done by the compiler. It's done, and then this bytecode is translated into the specific CPU machine language. You remember each CPU speaks a different language, right? So you translate the Java program into a specific bytecode, and that bytecode is translated into the specific CPU language. Okay, and therefore, Java bytecode is not tied to any particular machine. It is platform neutral. Any machine will translate the Java source code into the same bytecode. Then the different JVM, Java virtual machine, will interpret that bytecode into the local machine language. So we say Java is architecture neutral, platform independent, right? Once run anywhere. The difference is this, everybody. If you write a C++ program or a C program, if you write it on the Linux machine, some code might be a little bit different from the source code you write on a PC, from the source code you write on an Apple machine. So if you write a program, you want to solve a problem, and you write a program. If you write it on the Apple machine, you have to write it one way. If you write it on the PC, you write it a little bit differently. If you write it on a Linux machine, a Unix machine, you write it a little bit differently. Why? Because they have different CPUs. Okay, that's the difference. Versus Java, you write it exactly the same anywhere, and it can run anywhere. Why? Because when you download the Java system, you chose your CPU. You remember if you have an Apple machine, you click Mac. If you have a PC, you click the PC part, Windows part. If you have a Linux, you select the Linux package, right? That's why you selected the correct package, the correct download for your machine. It's because of that. Do you understand it, everybody? I know this is a little bit different, difficult to understand. So for Java, you have an extra layer. You have the Java program, Java bytecode, Java, and then the machine language, then execution. Okay, that's for Java. For other programming languages, you have the program, you have the machine code, you have the execution. Java has an extra layer, which is the bytecode. That's what makes it machine platform independent. Okay, any questions? Okay, let's go on. So you can see, right? Java source code, compiler, bytecode, interpreter, and machine language versus this very basic structure. Java program, compiling, execute. Versus here, program, compiling, bytecode, execute, right? So it's different. Okay. Development environment. Am I recording? Yes, okay. Development environment. We are using Eclipse. We call that integrated development environment because you can edit the program, you can compile it, and you can run it. That's why it's called integrated development environment, IDE. Okay. Oops. And these are examples, and we are using Eclipse, right? Okay. Now let's talk about this syntax and semantics. Okay, you already know syntax, right? Syntax rules are how you position the vocabulary, which are reserved words, what symbols can you use? That's the syntax rules. How you arrange those words into meaningful statements. Those are the syntax rules. Okay, semantics of a program means what your statements mean, what it wants to do, not what it wants to do, what it means. That's the semantics. A program that is syntactically correct is not necessarily logically correct. So when we say semantically, it simply means logically. That's what you want to do. Okay. A program will always do what we tell it to do based on the syntax, not what we meant to tell it to do logically. So that's, if you look at this program, and when you execute, you say, why do I have all those spaces there? I don't want those spaces. Well, you didn't want the space, but you wrote your program to include the space because you have them here, right? If you didn't want those space, then you are making a logical error. That means it's semantically wrong. Do you understand me, everybody? Are you all on mute?
No.
So if you say, I only want one space, right? I don't want any space, but you still have one space. So when you output, it still has one space, but you wanted no space. This is a logic error. So when you do your lab on Turing's craft, the code lab, when you do that, remember, it's not the program, it's not the question, the instructor or the author of those labs are picky. No, I'm not picky. It's the program, it's the compiler, the Java. This is the nature of programming. It's very picky. It's very detail oriented. If I say no space and you put a space there, that is wrong. If I say, give me the result of 2 and 3 added together. If you give me 6, that's a logic error, right? Because 2 plus 3 should be 5. If you give me 2 times 3, which is 6, then semantically, that's wrong. That is a logic error. That's what this is. Do you understand it, everybody? So you meant to give me the sum of 2 and 3, but you actually gave me the product of 2 and 3. That is the difference, okay? So syntactically, it's correct. It will run, it will compile and run, but you meant to give me the sum, but you gave me the product. That is wrong. That's the difference between syntax and logic error. The compiler can only detect syntax errors. It cannot find logic error. Okay, any questions? So if you look at this compile time error, we call it compile time because the compiler checks syntax. You remember that. So we call it compile time error, which is syntax error. Okay, read this. Right? So if you leave out a semicolon, that is a syntax error. If you forget the curly brace, that's a syntax error. If you do this, that's a syntax error because it should be system, right? If you forgot this L, you put I, that is a syntax error. Okay. So all those, this is syntax error. Very picky, I'm telling you. Okay. So those are syntax errors. Runtime errors. error conditions detected by the computer at runtime. That means it's compiled, it's translated to machine language. When it runs, it crashes. That's called the runtime error. I will give you a runtime error, okay? Let's see. 2 divided by 0 is, oh, I will not do that. We haven't done that yet, right? 2 divided by 0. Okay, I'm going to display this. And this will compile, as you can see. It's compiling, right? No errors. Let's run it. And now we have a runtime error. This is called a runtime error. You see, the first statement is okay. The second statement, it says arithmetic exception, divide by 0. That's a runtime error. Okay, it gives you, it tells you where it is, right? If you click on that, it tells you that is a runtime error because you cannot do divide by 0. You all know that. So once again, syntactically, this is great. But when you run, it happens. It crashes. Your program crashed. Look at the red. That means your program crashed. That is a runtime error. Logic error is the most difficult errors to detect and the most lethal, actually, because you are getting something that's not what you meant. Okay, errors in the program's algorithm, most difficult to diagnose. Computer does not recognize that error, okay? Example, 2 gallons. I will let you read the example. Okay, do you all understand this, everybody? Logic error, do you understand it? Yes?
Yes.
Okay, good, good. Okay, let me see what time it is. It's 10:47, right? And we are almost done, right? Okay. So we are now. Okay, let's continue. Let's continue. So you understand errors, problem solving. The purpose of writing a program is to solve a problem. I told you about this, right? Solving a problem consists of multiple activities. Understand the problem, design a solution, refine the solution, implement the solution, test the solution. These activities are not purely linear. They are, once again, overlap and circular, actually. So understand the problem. Remember just now when I asked you to write another statement to display something, right? I said, write another statement to display something. Some of you didn't understand me and you asked. So that is the part where you need to understand the problem, right? First, you need to know exactly what it is, what you need to do. Let's understand the problem. Design a solution. So I said, display something, and under this good morning again, it will display. And so you design your solution, you think, what statement should I use? Since I need to display something, I need to use, you see, that's the solution, right? And I need to use parentheses, I need to use double quotes, I need to put a semicolon. Whatever I want to say will be inside the quotation marks. That is your solution. And so, and think about, are there other better solutions? Are there better ways to do this? That's when you find the alternatives and refine the solution. Implement the solution. That's you actually write the code. You actually code your solution and test the solution. Run it and see if that's what you should have. right? So that's the activities. Those are the activities. I'm giving a super simple example here, just display something. But gradually you will see, I want you to solve problems. For example, you go to the grocery store, you buy several pounds of apples, several pounds of bananas, etc. And at the cashier, you need to pay. So how does that system calculate the total? That is the problem. And you need to find a solution to do that. So that is how you solve a problem. Okay. The key to designing a solution is break it down to many pieces. When writing software, we design separate pieces that are responsible for certain parts of the solution. That's why usually if you go to a company, you work in different teams, because one team will work on this piece, another team will work on another piece. Okay. Okay, an object-oriented approach lends itself to this kind of solution decomposition. We will dissect our solutions into pieces called objects and classes, and we will discuss that really in the second class. So in the first class, we will not discuss that. So any proper software development effort consists of 4 basic development activities. This is really just this part. Okay, how do you solve a problem? It's this here. Establishing. Yeah, go ahead. Someone has a question? No? Okay, establishing the requirements. So you know what is required of you to do, right? You have to understand the problem. That is exactly this. Understand the problem, right? Okay. Creating a design. That is design a solution. Implementing the design. That is writing the code, implement the solution. Testing. So it's basically the same. Okay. I should just delete that slide and keep this one, I think. Okay, I will let you read this. Okay, let me ask you, what is software design? What does that activity involve? What do you do during that phase? Software design. Basically, what are you doing?
Writing code?
Yeah.
Designing program,
figuring out what the problem you're going to solve.
Yes. Find the algorithm. I think someone said finding the algorithm. That's correct. Finding the algorithm basically means find a solution. And what is an algorithm? An algorithm is the step-by-step solution, a step-by-step instruction, detailed step-by-step instruction to solve. Basically, you are finding the solution. That's the design, right? What about implementation? What is that phase? What does that do? Implementation, what does that do?
Is that when you apply the problem solving to the solution?
You apply, how do you apply? Implementation, what do you do during this phase? Everybody?
Applying what you've built to the solution.
Implementation, what do you do? Apply the solution.
Try it out. Is that a better way of saying it? You're trying.
What do you mean by try it out?
Run the program?
Run the program before you write it?
You write it
You're writing the program.
You
You're
write the
writing-
program,
You're
everybody.
writing it to solve
You
the
write
problem.
the code. That's the implementation. Okay. So first you need to understand what it is that you need to do, right? That's the requirements. That means, what does the customer want? Do they want this? Do they want that? Do they want to have a round edge? Do they want to have a rectangular edge? You know, you need to know what they want. That's the requirements. Refine it, make it into details so that you don't have a legal obligation later on to defend yourself if they sue you, right? You always want to be very detailed. Make sure you understand the requirements, what exactly it is they want. After you do that, you design your solution, you find the algorithm, you find the solution to solve, to meet their requirements. And finding the solution is not the last step. You have to code it. You have to write the software. That's where your implementation is, write the source code. Okay. And then you need to test it. Why do you need to test it?
Make sure it works.
Yes, make sure it
Make sure it
works.
runs correctly.
And also it works correctly. That's very important. And make sure it's robust, it doesn't crash, and it gives you the correct result logically. Okay, so testing is also very important. And you can see that some companies, or they will hire testing engineers. It's not an easy task. You have to think of all the scenarios where it might happen, and you test it. If it happens the wrong way, you go back to the engineers and say, okay, in this scenario, it crashes. You solve it. You fix that problem, right? Okay, so that's testing. Any questions so far?
I got a question.
Yes, go ahead.
In testing, is that kind of like in cybersecurity where you're making sure like there's no way to, like, for example, like hacking or something? Is that like when you kind of make sure there's no holes or whatever? Is that kind of like that too?
Yeah, that's part of it. Yes. When you okay, in cybersecurity, you try to have no holes so that no one can attack you, but that's impossible, right? But in testing, it's impossible to exhaust all scenarios, but you try your best. And in that sense, yes, you're right. That's testing. You test your software and see where people can attack, can break their software. Yes, definitely. And you know that those hackers, the young hackers, teenagers, something, they go to prison and then they come out and they work for the FBI, right? Because they can hack into computers. So they are the best testing engineers, actually. Okay, yes. Any other questions? No? Okay. Java is object-oriented programming language. An object is a fundamental entity in the Java program. Objects can be used effectively to represent real-world entities. For instance, an object might represent a particular employee in a company. Each employee object handles data management related to that employee. This is very abstract. That's why I am reading it. It requires a whole class, a whole, when I say class, maybe a whole period of class to really explain the concepts. It's a difficult and abstract concept to understand. That's why I'm not going to discuss this in this class. Object-oriented programming will go to the second class. In that class, it's completely object-oriented. Okay, we will write classes, we will create objects, and we will touch upon those ideas here also. In chapter 3, we will actually touch it a little bit. But right now, you just need to know that Java is an object-oriented programming language. Everything in Java is an object. Okay. when we say an object, its blueprint is a class. So everything in Java is a class, it's an object. That's why when you write this program, if you look at it, okay, it's a class, right? So everything in Java is a class, which is the blueprint for object. And we treat real life, we treat programming, we make everything into an object, and then that object will function on its own and interact with other objects. So it's not easy to understand, I'm telling you. So we are not going to go into it here. Okay, everybody? Any questions so far?
What else are we going to cover